This is geometry, section 6.4, rectangles, rhombuses, and squares. So you've probably heard of all of those things before. We're going to formally define them in this section. So a rectangle is technically a parallelogram. This is a symbol, again, for parallelogram. So it's technically a parallelogram with 4 right angles. So all the angles and all the corners are right angles in a rectangle. So everything that applies to a parallelogram also applies to a rectangle. And there's also some new things that we know about rectangles that don't apply to every single parallelogram. So if you have a rectangle, then you also know that all interior angles are 90 degrees, which we stated up here. So all interior angles are 90 degrees, and we also know that our diagonals, so these dotted lines drawn in here, these diagonals are congruent always in a rectangle. So that's not always true in every parallelogram, but it is true in a rectangle. Also, if we look at the shading of these triangles, these dark shaded ones and then the lighter shaded ones, these are actually two pairs of isosceles triangles. So because of all of this that we know about rectangles, if we draw in the diagonals, that actually cuts this rectangle into 2 separate pairs of isosceles triangles, which is sometimes helpful when we're proving things. Or when we're trying to find angles, like this down here. So each figure below is a rectangle, find all the missing angles. So now that we know that we've got isosceles triangles, so just like we have up here, these 2 angles are congruent to these 2 angles, and the same over here. Similarly, these 2 are going to be congruent to each other, and these 2 are going to be congruent to each other. So all 4 of those are congruent, all 4 of these are congruent. So if this is 50 right here, we can start with this. We've got 50 here, here, and here. So we've got all 4 of those are 50 degrees. To find the other angles, we've got, since we know this is a right angle in all of these corners, if all of these are 50, then the ones on the other side of them are going to be 40, because 40 and 50 add up to 90, and they have to be a right angle. So all 4 of these are 40. So we've got isosceles triangles here, here, and then here and here. So to find the angles in the middle, we just add up the 2 angles that we already have in each triangle. So we've got 50 and 50, which adds up to 100. To find the third angle, we take that away from 180, and we get 80. So we have 80 here and here. And then to find these other 2 angles, we could do the same thing, add these up and subtract from 180, the 40 and the 40, or we could just say, all right, well, I know this is a straight line, so if this is 80, this has to be 100 so that it adds up to 180. So these are each 100. Same thing over here, start with 25. So we've got 25 in all of these spots. To find the other one, we would take 90 minus 25, which is going to give us 65. So we've got 65 in all of these spots. To find the ones in the middle, first we add up 25 and 25, which is 50. We take that away from 180 to find the one at the top. That leaves us with 130. So we've got 130 here and here. And then we could subtract 130 from 180 and be left with 50 here and here. Over here, now we're starting in the middle. So now we've got a 92 here, which means this is 92 because these are vertical angles. To find this other angle, we would have to take 92 away from 180 because these 2 have to add up to 180. So 180 minus 92 leaves me with 88. So I have 88 in both of those spots. Then we know that these are isosceles triangles. So this angle has to be the same as this angle, which is also the same as this and this. To find that, we would take 180 minus 88 minus this angle we already have. We would be left with 92, which is this number right here. So we know that these 2 angles, these 3 angles have to add up to 180. So if I take away the 88, these 2 angles have to add up to 92 together, and they're both the same. So we just take that 92 and cut it evenly in half, divide by 2. So when we do that, we get 46 for each of these. And then finally, to find the other 4 pieces, we know that the corners have to add up to 90, so I could just take 90 minus the 46 that's already here, and I would get 44. All right, so a rhombus. A rhombus is also a special kind of parallelogram. So a rhombus is a parallelogram with all sides congruent to each other. So a rhombus has all four sides congruent to each other, not just opposite sides congruent. So since it's a parallelogram, obviously the opposite sides are still congruent because all of the sides are congruent. So special things that we know about a rhombus. If we have a rhombus, then we know that the diagonals are perpendicular to each other, always in a rhombus. So I can draw in a right angle mark right here. The dotted lines are the diagonals. Also, we know that the diagonals bisect. Since it's a parallelogram, we know the diagonals bisect each other, but also if it's a rhombus, we know the diagonals bisect the vertex angles, which means these angles at the top. So that means that this angle right here is being cut in half, so each of these pieces are equal. And then these angles over here, each of these pieces are equal. A rhombus is made of 4 right triangles, just like a rectangle, or similar to the fact that a rectangle is made of 2 pairs of isosceles triangles. A rhombus is always made of 4 right triangles, which are actually congruent to each other. So this should say 4 congruent. Whoops. 4 congruent right triangles. All right, so each figure below is a rhombus. Find the measures of all the angles. So automatically, if we know it's a rhombus, we can do this. We can say all 4 of these in the middle are right angles. Automatically, if it's a rhombus, we know the diagonals are perpendicular, so it's always a right angle in the middle. Also, the diagonals bisect the vertex angles, so everything right next to each other is going to be the same. So if this is 28, this is 28, this is 62, this is 62, and it's the same across the rhombus. So 62, 62, 28, 28 means this is 28, 28. Simple as that. Here we've got 44, so this one right next to it's 44. These ones all the way across from it are also 44. Now we're not given the other number, so to find these other 4 angles, we just have to add up this 90 degrees, this 44 degrees, and then subtract that total from 180. So when we add that up, we get 134. If I subtract that from 180, I get 46. So all of these are 46. The ones right next to each other are always the same, right next to and across. Since it's a parallelogram, the opposite angles, the ones across from each other, have to be the same. All right, over here, 58 means 58 right next to it and across from it. And then to find the other one, we take 90, add 58, we get 148. And we would subtract that from 180 to complete the triangle. That gives us 32. So all 4 of these other missing angles are going to be 32 degrees. All right, so as I've stated, if a statement is true for a parallelogram, then it's always true for a rectangle and a rhombus. So anything that applies to parallelograms that we learned 4 things, 5 things actually. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. All of those things are still true for rectangles and rhombuses, in addition to the other things that we just learned. So this is a lot to keep track of. All of this right here, we've got a bunch of different statements. We have to decide if it's true for parallelogram, rhombus, and or rectangle. So it says to put a checkbox if the figure has a stated property. That means it always has that property. It could sometimes have a property, but we're only going to put a check mark there if it always has that property. So anytime that we check the box for parallelogram, we're automatically going to check the box for rhombus and rectangle, because anything that applies to a parallelogram also applies to a rhombus and a rectangle. So the first one says the diagonals bisect each other. Well, that's one of the 4 things we learned about a parallelogram, so that's also true for the other 2. Diagonals are congruent. That is not always true for a parallelogram. That's one of the things that we learned today about a rectangle. Diagonals bisect the vertex angles. That's not always true for a parallelogram. That's one of the things we learned today about a rhombus. Diagonals are perpendicular. We also learned that about a rhombus. It doesn't always apply to the other 2. All vertex angles are congruent. That does not apply to a parallelogram. Only opposite angles are congruent in a parallelogram. This does apply to a rectangle, because in a rectangle, all the vertex angles are 90 degrees. So obviously, they're all congruent to each other. Opposite vertex angles are congruent. That is what we learned about a parallelogram, so it also applies to the other two. Consecutive angles are congruent. So we learned that in a parallelogram, consecutive angles are supplementary, but, so this doesn't apply to a parallelogram, but in a rectangle, all the angles are congruent, so obviously the consecutive angles are congruent. So that applies to a rectangle. Consecutive angles are supplementary. That's what I just said. We learned about a parallelogram, so that applies to all of them. Opposite sides are congruent. That is true about a parallelogram, so it's true for all of them. Opposite sides are parallel is also true. That's true for all of them. All sides are congruent. That only applies to a rhombus. That's part of the definition of a rhombus, that all of the sides are congruent. And consecutive sides are congruent. We haven't really talked about consecutive sides. This only applies to a rhombus. All right, so an example, RATE is a rectangle, so we have to use what we know about rectangles to solve for these variables. We're told that this piece, RS, is 2x plus 1. EA, this entire diagonal, is 26. And since it's a parallelogram, since it's also a rectangle, that means it's a parallelogram. So if this entire thing is 26, that means each piece is 13. So we can we can write 13 for each of those pieces, and it says AT is 4x minus 13. So since it's a parallelogram, we know that we can do this. We can write that each piece is 13. Since it's a rectangle, we know the diagonals are congruent to each other. So if each of these pieces right here is 13, that means all 4 of these pieces are 13. So to solve for x, we can take 2x plus 1 equals 13, and then solve for x. Divide by 2, so x equals 6. Now it's asking me what's the length of RT. Well, RT is going to be the same as EA, since the diagonals are congruent in a rectangle. EA was 26, so RT is also going to be 26. RE, we have to find this side, which is going to be congruent to this side, since it's a rectangle. And we've got 4x minus 13 is this side, and we now know that x is 6. So 4 times 6 is 24, minus 13 gives us 11 for that piece. Down here, this figure is a rhombus. We have to find x, y, and the perimeter of the entire figure. So to find x, since it's a rhombus, it's right here for us. A rhombus, we know all the sides are congruent. So if this is 17, x is 17. Right here, y, it says y degrees. So how many degrees is this angle? Well, since it's a rhombus, we automatically know that the diagonals are perpendicular. So this has to be a 90-degree angle. So the perimeter, we know all of these are 17. We would just add up 17 4 times, or multiply 17 by 4, and we would get 68 inches. All right, a square. So rectangles and rhombuses are the more complicated ones. A square is just a combination of a rectangle and a rhombus. So anything that applies down here, anything that applies to a rectangle and a rhombus also applies to a square. And since anything that applies to a parallelogram applies to a rectangle and a rhombus, it also applies to a square. So anything that applies to a parallelogram, rectangle, or rhombus is also true about a square. So it says find all the angles in the square below. Well, since we know it's a rhombus, we know the diagonals are perpendicular. So we can do this, say that everything in the middle is 90 degrees. Since it's a parallelogram, we know the diagonals bisect each other. So we know all of these are congruent, which means, and since we know it's a rectangle, we've got isosceles triangles all the way around. Since it's a rectangle, since it's a rhombus, we've got also that the diagonals bisect the vertex angles. So if this is a 90-degree angle, since it's a rectangle, if I cut that in half, it's 45 degrees all the way around for every single one of these 8 angles. So if I have a square and I draw in the diagonals, I create 4 congruent triangles, each with 2 45-degree angles and a 90-degree angle.